All right. Today we're going to be talking about representation and comparison of rational numbers. The TEKS that we're going to be going over are 6.2a, 6.2c, and 6.2d. The questions that I pulled from are from previously released STAR questions, which you can find on Lead Forward. Let's begin. So, our first one is 6.2a, and it is from the 2016 test. The question states, which graphic organizer correctly groups the following numbers? 3.4 or 3 and 4 tenths, -2, 3, and -1.2. So, you look at your answer choices, we have to classify them between rational numbers, integers, and whole numbers. So let's quickly talk about what those are. I have other videos concerning this topic, but let's talk whole numbers. They start with 0. Whole numbers. They start with 0, 1, 2, 3, 4, 5, 6, comma, 5, yada, yada, yada. Goes on forever. So what are whole numbers? They don't have a decimal or fraction. They are positive, but it can include 0 because 0 is neither positive or negative. And it goes on infinitely. There's an infinite amount of whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, yada, yada, yada. It goes on for forever. Those are whole numbers. So what are integers? Integers are whole numbers, including 0, and their opposite. So 1, what's the opposite of 1? -1. Just means it's on the opposite side of the number line. So what's the opposite of 2? -2. What's the opposite of 3? -3. What's the opposite of 4? -4, so on and so forth. So integers go infinitely this way, go infinitely greater, less than. They do include 0, and so it's just a whole number and its opposite, and it does include 0. Integers don't have a fraction or a decimal. It can be positive or negative. That's how they're different than whole numbers, because whole numbers have to be positive, including 0. The integers can be positive or negative. Okay? So what the heck is a rational number? Well, I'm glad you asked. A rational number includes all the numbers I just went over, whole numbers and integers. A rational number is any number you can be written in the form of a over b. It's a whole number. It's an integer. It's a fraction. It's a repeating decimal, because 1/3 turned into a decimal, divide the numerator by the denominator, you're going to get 0.3333. It goes on forever. So a repeating decimal. A terminating decimal, so if I had like 1/4, because that's in the form of a over b, turn 1/4 into a decimal, I'm going to get 0.25, 25 hundredths. So a terminating decimal is rational. And of course, and these include both positive fractions in decimals and negative fractions in decimals. And I could have -5 and 2 tenths. All of these would be rational number because I can write them in the form of a over b. All right. So if you look at your answer choices, so -2 is not a whole number, so it can't be that. So they have whole number 3, check, check, check. They have integers, -2. On an integer, it can't have a decimal or a fraction, so it can't be that. That's wrong. And it can't be this, so that's wrong. Let's just double check, make sure I'm doing it right. Rational number, any number that can be written in the form of a over b. These have a decimal, so they can't be a whole number or integer, but they are rational. So this is correct. Our answer for this particular problem was F. All right. Let's go to the next problem. Again, we're at 6.2a, which where we have to classify whole numbers, integers, and rational numbers using a very visual representation, such as a Venn diagram. So from the 2015 test, 3 sets of numbers are shown in the Venn diagram. So we look at our Venn diagram. We have whole numbers, we have integers, and we have rational numbers. Now notice, I'm going to erase all this, notice we have a shaded area right here. So they want a number that could be all of those. So we classify things all the time. But this time we want something that could be a whole number, that could be an integer, and could be a rational number. So whole numbers, 0, 1, 2, 3, 4, 5, don't have a decimal or fraction, but they're positive. Integers Again, it's the whole numbers and their opposite, including 0. Rational, any number that can be written in the form of A over B. So it has to be all of those. So the most specific of those is whole numbers. So which of these numbers can be placed in the shaded area of the diagram? Well, are any of these whole numbers? So -5 is an integer. It's a rational number, but it's not a whole number. What about 3.53 and 5/10? Well, it's a rational number, but it's not even an integer, so it can't be that one. What about 1/2? 1/2 would be rational because it's in the form of A over B, but it's not an integer because integers don't have decimals or fractions, so it's not that one. So which one would classify, what could be in all three classifications? Well, it's none of these, so it's not here. What could go there? Well, we could have 0 or 1 or 2 or 3 or 4 or yada yada yada, so on and so forth, because each of these would classify both as, well, as a whole number, as an integer, because integers are positive or negative. Okay, they can be integers can be positive too, no decimal, no fraction. Or obviously these are rational numbers. You can write all of these in the form of A over B, including 0, because you could have 0 slices of pizza out of 2. You could start off with 2 slices, eat them, and you have 0 left. So that definitely is a rational number. All right. We're on to question 18. So I believe this is 6.2c. Dana, place the following points on a number line. Okay. So you can see point P, point Q, point R, point S, which is not correctly placed on the number line. So me personally, let's go ahead and turn these improper fractions into mixed numbers. And then you can turn them into decimals if you want. I don't think it's necessary on this problem to turn any number into a decimal, any fraction into a decimal, I should say. You divide the numerator by the denominator. So let's start with -24 over 3. So again, just to turn it into a mixed number, I have an improper. I know the negative sign's right here. I'm just going to say it's -24 over 3. Top in, bottom out, divide the numerator by the denominator. This goes in evenly, and so my answer, divide the negative by positive, you get a negative, so it's -8. So point P, they placed, I'm going to do this in red, point P, they placed there. We got -8, they plotted point P at -8, so that is correct, and we're looking for what they did not place correctly. So they did do point P, so that's not the answer. So let's go ahead and cross out F. Okay. All right, I'm going to erase this. Give me a little room here. All right. So next, point Q. So point Q, it's in between -4 and 3. So it gets a little confusing on negative numbers, but what's in between -4 and 3? Think about owing money. What's in between owing $3 and $4? You can have that looks like it's halfway in between, so it'd be around -3.5. I would owe you -$3.5, $3.50. Okay, so let's look at -9 over 2 gives us -3.5. So, I'm going to erase this, gives a little room. So, -9 divided by 2, a fraction bar is a division bar, so -9 divided by 2, we'll write it this way in case that helps you a little bit. And so 4 and 8, I get 1, and a decimal. Actually, let's keep it as a fraction, so that's -4. Numerator, denominator stays the same, so it's -4.5. Well, -4.5 should be in between -4 and -5. It's halfway in between 4 and 5 on the right side, so it's still halfway in between -4 and -5 on the negative side. So point Q should be here, but it's not. They place it in between -4 and -3, so that is our answer. But let's very fast check the other ones, just to make sure I didn't make a mistake. So we have point R is 7 over 2. Let's divide 7 by 2, and we get 3, 6, and 1, so it's 3.5. So halfway in between 3 and 4, and they did that correctly, so it's not that one. And then 15 over 3, divide 15 by 3, you get 5. They placed S at 5, so that's correct, so it's not those either. So again, we were correct in point Q, because again, they didn't place it in between the correct integers. All right, so next problem. Now this is 6.2d. The table shows the portion of a day 4 students used to build a website, which this shows the students in order from greatest amount of time used to the least amount of time used. Now if you noticed, we have decimals and we have fractions. So the easiest way to do this is to get all of them in the same format. So on these, I'm going to turn them all into decimals. Now you can say, Mr. Hewlett, aren't these already in decimals? Technically, yes, but we need to get rid of the percent so we can actually compare them, okay? So the easiest way is 29.4%. Percent means out of 100. So technically, we're just going to be, this is 29.4 over 100. To turn it into a decimal, divide the numerator by the denominator. Now the trick is when you're dividing by 100, the first number is a 1. Pretty easy to pick up on, and you have 2 zeros. So the easy trick on this is if I'm multiplying by 100, I'd move my decimal 2 places to the right. If I'm dividing by 100, I move my decimal 2 places to the left. So 29.4, 29.4 tenths, divided by 100 is 0.294. So again, I'm dividing by 100 because percent means out of 100. Fraction bar is a division bar. And the easy way to remember this, dividing by 1, so the number's not going to change. But then I have 2 zeros, and that's just moving the place value. How many times? Well, you have 2 zeros, so 2 times, and 2 times to the left, so that gives you 0.29. I'm going to erase this and write it over here. 0.294. Now we're going to do 37.6, 37 6/10. Divide it by 100, so loopy, and that's going to give you 0.376. Now let's do 7 over 25. Now there's 2 ways we could do that. We could divide the numerator by the denominator, but this one I have what I like to call a pretty fraction, which means I know how to go from 25 to 100, which is times 4. In a fraction, whatever you, property of 1, whatever you do to the bottom, you do to the top. Whatever you do to the denominator, you do to the numerator. And then 7 times 4 is 28. And of course, as you guys know, 28 hundredths, if I just read it correctly, 28 hundredths is, that's right, 28 hundredths. Now notice my top 2 numbers have 3 numbers to the right of the decimal, so I'm just going to add a 0 there. All right, and 3 tenths, similar to the previous one, I could divide the numerator by the denominator. This one, I have another pretty fraction. How do I go from 10 to 100 times 10? Whatever you do the denominator, you do the numerator. That's going to give me 30. And 30 hundredths, that's right, is 30 hundredths. And again, I'm going to add an extra 0. And I like to line up my numbers by place value vertically. It's easier to compare. So I'm going for the greatest. So obviously, I have zeros in the ones place. I look at the tens place. 3 is greater than 2. Now I'm going to go to the tenths place. And so between this one and this one, which one's greater, 7 or 0? Obviously 7. And so that's Andrew. Andrew has the greatest amount of time. So Andrew is first. So that crosses out G and H. All right, so if Andrew is first, we'll write first here. And then Blake is second because he had a 3 in the tens place. So, well, shoot, on this one, it's not Blake second, so Blake's out. Let's just make sure we did it correctly. So now we've done these 2. So now 2 and 2, all right, they're the same. Let's look at the tens place. 9 or 8, obviously 9 is greater, so that is third, and that's Jamal. And so that's correct, and Ernesto is last. And that's all right. All right, so that's how we did it. Turned all the numbers in different formats, turned all the numbers into decimals, lined them up vertically, so it's easier to compare them. Place value, and then figure out which one's the greatest, which one's the least. And again, we showed you how to turn a percent into a decimal. Percent means out of 100, so you're just moving your place value 2 times to the left. And then the fractions were easy. Either you could divide the numerator by the denominator, or on these we had pretty fractions, and it's easy to go from the denominator to 100. All right, which of these shows the numbers? And this is 6.2D. It's from the 2018 test. Which list shows the numbers in order from least to greatest? Now, always pay attention. What are they asking? Because I'm sure you've made a mistake, like I have when I rush through something. Pay attention. Are they asking from least to greatest or greatest to least? So again, we have different forms of the numbers. So I'm going to turn all these into decimals. And don't be afraid to check your work with the calculator. So I'm going to go ahead and do these kind of quickly. So negative 2/5 is negative 0.4. I'm just starting with F. I don't know if it's F, I circled F, but I'm just saying I'm starting with these numbers. I'm putting them in, I'm just converting them into decimals. I don't know if this is the correct answer. We'll see. And the next one, well, it's already a decimal for me. Well, that's easy. Negative 2.5 is pretty easy because I know 1/2 is 0.5 because half of a dollar is 50 cents. I'm going to add a 0 so they all have the same amount of digits. 5 is 5, and I'll just add a 5. 0.00, and 21 over 4 is 5.25. If I had 21 quarters, it would be $5.25. So I want the least value. Now on negative numbers, the bigger the number, the less it is actually. And again, think of money. I would rather owe 40 cents than $2.50 because $2.50 is farther left on the number line. Since it's farther left, I'm going to go ahead and erase this. I can go ahead and tell you it's not F. So again, I'm looking for the least value, and if it's negative, I'm looking for the number that's farthest left on the number line, and a number line would be a great tool if you're struggling with this. So negative 2.5, which is negative 2.50, is the least number because it's farthest left on the number line. I do not want to owe $2.50. I never want to owe money, but that is, if the absolute value is its greatest number, it's the farthest left on the number line. So it's either H or J. Now the second number, if I'm going from least to greatest, this is my least, and then it's going to be this one, negative 2.47. Of course, both of them are negative 2.47. So that doesn't help me. Next, I'm going to go to my negative value that's closest to 0, which is negative 2/5, which is this. All right, they have those both correct. Now, if you look at H and J, they've switched the last two numbers. So which one is it going to be? Now, if it's positive, obviously, the bigger the number, the greater it is. Again, it works a little differently when it's negative. Okay, the bigger the number, if it's negative, the less it is. And again, just place it on the number line if you get a little confused. So which one is it, H or J? And obviously, it is H, because 5 is less than 5 and 25/100ths, or 21 over 4. So H is my answer. I believe that's it. Oh, we got one more. So again, which list shows, and this is 6.2D, which list shows the amount of homework completed in order from greatest to least? Again, we want to pay attention to which one's greatest to least, or least to greatest. This time we want the biggest number. So I'm going to turn all these numbers into a decimal. This one's easy. 45 over 100. Divide the numerator by the denominator. Now you can have a number greater than 0 on this. I'm running out of room, so I'm just going to go ahead and do the math. And 100%, what does percent mean again? Out of 100. And what's 100 divided by 100? 1. I'm going to add some zeros. And the last one is 2/3. Divide the numerator by the denominator. You're going to get 0.666. Now the 6 goes on forever, but I'm going to stop at the thousandths place because I don't need to continue going. All right, so now that I have converted all my numbers, my decimals, fractions, percents, into decimals, of course I guess the decimals pretty easy, I'm going to line them up vertically and then compare them. Now, I want the number that is the greatest, again, greatest to least, so I'm going to start with the ones place. So obviously 1 is greater than 0. Then I go to the tenths place. And obviously 1, again, is greater than 0. So this number, 45 over 40, is the greatest. As I look at my answer choices, I already know my answer is B. Let's just prove it. So next, I go to the other number that had a 1 in the ones place. So 1.0. Again, 1 is greater than 0. So it's Grace, and so this is second greatest. And then now I'm done with my ones place. I'm going to go to my tens place. Which one is greater, 6 or 4? And obviously 6, so that's Jonah, which is 2/3. Again, we got that correct. And the last one is Katie at 0.44. All right, so we've gone over some problems from the Release Star questions over 6.2a, 6.2c, and 6.2d on representation and comparison of rational numbers. So hopefully this has made sense and this has helped. If you have any additional questions, you can email me at jhewlett@leisd.ws. Thanks and have a great day.